Now let's talk about a pattern that comes up a lot when it comes to arrays, and that is prefix sums. Prefix sums actually aren't super complicated, and they usually don't require any super crazy data structures or algorithms. The idea is that if we have some array, a prefix sum is defined as being, first of all, let's talk about the word prefix here. A prefix basically means that we're starting at the beginning. So prefix. So a prefix of this array is any subarray, any contiguous subarray typically, that starts at the beginning of this array. So this is one prefix of the array. Another prefix would be the first two elements, and then we could add another, and now this is a prefix, and then add another, and this is a prefix, and this is a prefix. The entire array itself is technically a prefix of itself. Now, this is not a prefix because it does not start at the beginning. And this is not a prefix usually because while it starts at the beginning, it's not contiguous. Typically, prefixes are contiguous blocks that start at the beginning. And typically with prefixes, now extending that, a prefix sum would basically be any prefix of this array, would basically mean for any prefix of this array, we also calculate the sum of that prefix. And you'll see why we do that and why it can be helpful and make things more efficient. So this prefix sum would just be 2. This prefix sum would be 2 minus 1, which is 1. And now there's a bit of repeated work actually, because if the prefix sum of this is 2, the prefix sum of the first two values is 1, how do we get the prefix sum of the first three values? Well, we already know the prefix sum of this, and then we add 3 to it. So we take 1 plus 3 and we get 4. Now to get the prefix sum of the first 4 values, we can take 4 minus 3, which is going to give us 1. To get the prefix sum of the entire array, we can get 1 plus 4. That's going to be 5. Now, even though we're talking about prefix sums, generally under this pattern, you could do other things. Another common thing is prefix products. So what we did was the sums, but you could also calculate the product. So for this prefix, the product would still be 2. For this prefix, the product would be 2 times -1. That'd be -2. The product for the first 3 values would be -2 times 3. That'd be -6, and etc., etc. You could do that. And sometimes that's also a pattern. The main thing that we're worrying about here is the commonality between that is that it's a prefix. Now, there's also another thing called postfix, which is sort of the opposite of a prefix. With prefixes, we have every subarray starting at the beginning. A postfix would be every subarray starting at the end. So this would be a postfix. This would be a postfix. This would be a postfix, etc., etc. Basically, prefixes and postfixes are two sides of the same coin. Because generally we use prefixes to eliminate repeated work. Let me show you what I mean. The classic problem with prefixes is that we're given an array of values. So that this would be our array in this case. We want to design a data structure that can query the sum of a subarray of values. That sounds more complicated than it is. Basically, that means that we could call some function called maybe query sum and pass in 2 indices left and right. So maybe in this case, this is our left and this is our right. And this function could calculate the sum of this subarray. Now, the naive way to implement a data structure that could do that is basically not worry about prefixes, just have an array given 2 indices. It's pretty easy to calculate the sum of that subarray. Just go through every position, add it to some total, and then return that total. So while this is an easy problem to solve, it can be done more efficiently because the naive way to do it would be, in the worst case, an end time operation every time we call query sum. But using prefix sums, we can actually eliminate pretty much all of the repeated work. Let me show you how. Now, while none of our prefix sums that we calculated will give us this calculation that we want, and that's expected because we have an array of, let's say, n values, the number of subarrays we could have is n squared, right? We could have, this subarray, this subarray, this subarray, right? These are prefix subarrays, but we could have other subarrays like that, like this. And our prefix sums only tell us the sums of every subarray that starts at the beginning. They don't tell us the sums of these. We haven't pre-computed that, but we don't need to actually. Because while we're looking for this sum, we can get pretty close with this value. This value will tell us the sum of all of these values, right? So that's what we want, except we want to chop off this value. So how do we do that? Well, we take the prefix sum of all these, which is this, subtract from it the prefix sum of all of these values, and there was only 1 in this case, so we'd take 1 minus 2, and then we would know that the sum of this subarray is 1 minus 2, which is -1. And when you just look at the values individually, 3 minus 1, that's going to be -1. So that is the case here. Doing the exact same thing for this subarray, we would want the prefix sum of the array up until this point, which is 5. But we'd also want to remove this prefix sum, the prefix sum of these 3 values. So we would take 5 minus 4, because we know 4 represents the prefix sum of these values. So 5 minus 4 is going to be 1, and looking at the values individually, that is the case. The sum of this subarray is indeed 1. Now, because we pre-computed these prefix sums, every time we're given any arbitrary subarray, we can get the prefix sum in O of 1 time, because we're just doing a single calculation. We're taking some value, subtracting another value, and that gives us the sum of that prefix. So this is one of the most classic prefix sum problems. There are many others just like this problem that kind of use a similar idea of pre-computing work using prefix sums, and then that makes additional work that we need to do a lot easier. Now, I also mentioned that prefix sums and postfix sums are just two sides of the same coin. And the reason is because we could solve this problem the exact same way using postfix sums instead of prefix sums. Maybe you can even think of how we could do that, assuming that the values that we computed here were actually postfix sums and not prefix. That means that the value here would represent the sum of this subarray, and the value here would represent the sum of this subarray, the value here would represent the sum of this subarray, etc., etc. Then, if we wanted the sum of this subarray, we would just take this value, which would represent this sum, and then subtract from it this value, which would represent this sum. That's why postfix sums are pretty similar to prefix sums. But now let's take a look at the code. So the code for our data structure could look something like this, where our constructor is given some array of values. Let's assume we're only given a single array of values, and that's it. We're not going to be given a new array every single time, so that when we pre-compute the work, that we don't have to continuously do that. We only have to pre-compute the prefix sums a single time. So given some array of nums like this one, we're going to initialize our data structure by computing the prefix sums, just like we have shown over here. So we'll have a member variable array called prefix. We'll keep track of our total, because calculating the prefix sums is pretty easy. Initially, our total is going to be 0. We're going to go through every number, so 2, and then we're going to add that number to our total. So our prefix sum so far is 2. And then we're going to append that to the prefix array. Then we're going to get the next value, which is -1. We're going to add that to our total so far, and that's going to total to be 1. We're going to add that to our prefix sum array, and we're going to just keep doing that. 3 plus 1 is going to be 4, and then -3 plus 4 is going to be 1, and then 4 plus 1 is going to be 5. So we only do that once. Now when we want to calculate the range sum of any subarray, we can do it in constant time. Because we did the pre-work here, we did an O of n work to initialize the prefix sums, now we can do the range sums a lot quicker. If we solved this problem without prefix sums, we just had a single array, our constructor would have been efficient, because all we would have done is just copied nums into like a member variable. For that, that would have been a constant time operation. But our range sum would have been a linear time operation. And assuming that we're going to be calling range sum very frequently, and we're not going to be calling, the constructor very frequently, that's why solving this with prefix sums is more efficient, because we're assuming that range sum is going to be called more frequently. Now, range sum is not super complicated. So assuming our left and right indices were this, and assuming our left and right indices were this for one call to this, we would want the prefix sum of the right portion. So where our right pointer ends, we'd want the total sum of this, which we could just get from this index. So that's exactly what we're doing here. We're taking the right index and getting the value from our prefix sum array. So this is the right prefix. So this is the right prefix sum. We also want the left prefix sum, which is just as easy. We just take the value at the left index of our prefix sum array. But what about the case where we're computing this prefix sum? And then we'd also want to remove the prefix sums of all values to the left of our left pointer. So that is just as easy because we would just take the prefix sum of left minus 1. So you can see that over here, but there's one catch, because what if we were computing this range sum? Well, in that case, the left minus 1 index is out of bounds. We definitely don't want to go out of bounds. There's nothing there for our prefix sum anyway. So how would we calculate the sum of this subarray anyway? Well, we know that this value here would represent this sum, and we would go left minus 1 over here and then subtract that value, but that's out of bounds. So what should the default value be over here that we want to subtract from our total? Well, the default value should just be 0, right? Because we don't want to subtract anything from this sum. This sum tells us the value that we want to return, right? Like this value tells us the prefix sum, which is the sum of our subarray. So what we say is, over here, I do this with a ternary operator, but you can actually have like a full if-else statement if you want. I just think this is shorter, and this works in most languages with a ternary operator. But we want to do this if our left pointer is greater than 0. But if our left pointer is equal to 0 exactly at that 0 index, then we want to set this to a default value of 0. And then once we have that, we simply take the right prefix sum. So for this example, that would be this value, and subtract from it the left prefix, which would be this value. So that would tell us this sum. Subtracting this sum would give us 0, because 1 minus 1 is 0, and that's what the sum of this subarray is. So that's how we would do it. So I think this is one of the patterns that isn't super crazy, especially once you get familiar with it. It comes up a lot. This is definitely one of the most common patterns when it comes to data structures in general, even in coding interviews. And luckily, it's not super crazy. So I definitely recommend practicing this pattern. There's a ton of problems that can be solved using prefix sums or postfix sums, or sometimes prefixes without sums. Maybe it'll be a product or something else. It's a pretty open-ended pattern.